A few words about me before we get started. So I'm Uri, a Google developer expert for web technologies, and now also the Google Assistant, which means I go and speak in conferences, write blog posts. And if you are sharpshooters, you probably noticed that I also work part-time for BlackBerry. Yes, they still exist. I also dance salsa, I play on the pan flute, and I couldn't resist playing something short for you. So let's see if you recognize this. Wait, I haven't played yet. Okay. That's all I know to play. Thank you. So today we are going to talk about technology I'm really excited about. Not this mic, which does have some buzz. It's called Web Bluetooth. And Web Bluetooth basically allows you, developers, to connect hardware to your web apps. And before we start with the really deep dive stuff, a few words about Web Bluetooth. So Web Bluetooth is available today. I always get asked, okay, this is cool, can I use it? So yes, you can use it. It's available on Android 6, on Mac in the latest Chrome, Linux, Chromebook. Anybody uses Chromebooks? I thought that. Linux, it's not yet available on iOS, but there is a custom web browser so you can get from the App Store that polyfills that. So basically, except from iOS, it's pretty much everywhere. And what we are going to do with Web Bluetooth today is, as Martin spoiled my surprise. Is it? Okay. We are going to use a nice device. The device is called Muse. And Muse is a EEG headset. What this basically means, it sits on my head and it reads the electrical activity from my scalp and sends it to whoever wants in Bluetooth. So you can also connect and read my mind. It's not really secure, this device. Anyway, let me try to get it connected fast before you do. I had one time in a talk where somebody from the audience connected to it. It ruined the whole experience, so please don't do it. I'm putting it on my head, and I'm going to use an Angular app. I hope it will work with the mic. I haven't tested that at home. And I'm going to use an Angular app that I created. It's open source. And this app will use Web Bluetooth to connect with my headset. And I also just, this is another thing I do. I do augmented reality. So this is Alisa with an augmented reality Viking. If you want an AR Viking selfie after, come to me. Anyway, I posted the link to a blog post I wrote. It's like the slides for this Twitter, so you can, on Twitter, so you can check it later if you want. And it also has a link to this Muse EEG app. And what I'm going to try to do now is to connect with my Muse. Hopefully, I switch it on and it works. Are you on, Muse? This is the most dangerous part of the talk, live demos. Let's try this, see if it works. It's looking for connection, connecting, and it's connected. Okay, thank you, but you have seen nothing. Okay, so after a really successful first demo, let's make sure it sits well. Sits correctly, and let's give it a moment to settle. And as you can see, this is my brain activity right now. Nothing much going on there right now. One thing I want you to notice though, look at the graph while I blink. Actually, it's not as good as I wanted. Let's try that again. Hold still. Now, look at the graph as I blink. Do you see it? Blink, blink, blink. Let me even zoom in a little more. I am blinking, 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 blinking. Now I lied, I didn't blink. You could probably tell by the graph. Anyway, whenever I blink, you see this spike in the graph. So what you basically see here is the recording from 4 places around my head. These are like the technical term. TP9 is my left ear, left eye, right ear. And this is basically the electrical activity around my scalp. And whenever I blink, I create electrical activity here on my left ear and on the right one, also in the eye. You can read more about like the scientific part of it on my blog post if you wish. But right now, I'm going to show you another feature just because it's fun. It's built with WebGL and it visualizes the head position of the headset. And what are we going to do with this today? We are going to use RxJS. I know there was a talk from Michael, I can't say his last name, something, 2 hours, about an hour ago about RxJS. So I guess there are RxJS developers in the audience. Nobody does? Somebody? A few buddies? Martin? RxJS? Okay. So we are going to use RxJS to process this data from the EEG headset. Hopefully it will be a little bit less noisy in our Angular app. And we're going to do it live, so it would be more interesting. I hope it will also work. So let's get started. Basically, we're going to use Web Bluetooth to connect to this device and get this data and process it with RxJS and visualize it. So I started a new project, call it Viking Brain. Let me also add a Muse.js library. It's basically a small library that reads the data from the device using Web Bluetooth and converts it into RxJS observable so you can subscribe to it. And while Yarn is linking dependencies, let me tell you that we are basically going to use a few operators, some basic ones like filter and map, and some more advanced ones like switch maps. Anyone is familiar with switch map? More people that are familiar with RxJS. That's interesting. Thank you for waking up. Anyway, so we are going to do it, and then if we have some time, I have a small surprise for you, and that's the donut over there. Yeah. Yarn is being really slow today. So while Yarn is doing its thing, let me open VS Code. So this is VS Code, the new project that I have just created. You can see here I have this app component. This is just the default Angular app that you get with the ng CLI when you do ng new. And Yarn is completed, so I'm going to start Webpack, and guess what? It's probably going to take a few more seconds. I love when it says 92% chunk asset optimization. Only 10%. Okay. So anyway, let's be optimistic and wait for Webpack to finish. And we'll get welcome to the Angular app in a moment. Yes, welcome to our app. And the first thing we're going to do is just remove everything from the screen and start from scratch. Let's say H1 ngVikings and put some. Did you know there is a new emoji for the brain? ngViking emoji, just to see if the setup works. It works, perfect. And then the next thing we're going to do, we want the user to be able to connect to the headset. So we're going to create a connect button, connect, and again the brain emoji. And on click, I will call the connect method, which we will implement in a moment. Save this, open our controller, and implement the connect method. It's simple as that, connect. And basically, I'm going to use now the Muse.js library we just installed. So I will import statement from Muse.js. I'm going to import the Muse client. Now I'm going to do a nice thing to fix the TS lint warning. That's a nice VS Code plugin that automatically fixes lint warnings. And now I got this Muse client class that wraps the Web Bluetooth API for the Muse. I'm going to create an instance, new Muse client. Thank you, TypeScript, for auto-completing. and I'm going to connect with it. As you can see, the connect method, oh, this muse. So this is live coding. If you see any errors, tells me it's us together. This does muse, does connect. This return a promise, and I'm lazy, so I'm going to use a new feature in JavaScript called async await. Basically, this means wait for the promise to resolve, do some magic, and then when you get to the next line, the promise has already been resolved. And then the next thing, I'm going to call the start method. It also returns a promise, and this method just tells the headset to start sending data. Now that I have done this, I need to print something to console, so we'll know everything is fine, connected, cool. And then the next thing we'll do, we'll actually start looking at the data. So this is the EEG readings. It's an observable, and we are going to print data. We just print whatever it sends, so we'll see what the data that is coming from the headset looks like. I'm going to save, hit the connect brain button. I like it. It's why doesn't it work? Updating, recompiling. I should really get a faster CPU. Anyway, I think, oh, it's still connected. Interesting. I'll switch it off, then on, just to make sure we are on the same Bluetooth. And let's see if it pairs now. Connected, yay. And now I should start seeing data coming, hopefully. Will I? Won't I? Let's see, subscribe, console log. That looks legit. Let's try connecting again, maybe. Connected. No data coming. Maybe if I move it off my head, I will see some data. Or well, no data coming. I'm going to try to refresh the page and do it again. By the way, remember, if you see any error, report it. Connecting to the muse. Will it say, oh, finally it worked. Moral of the lesson, if it doesn't work, refresh and try again. Then unplug the computer, restart it, etc. Anyway, so what are we getting? We are getting a lot of objects that have a few properties. Electrode is just the place where I get the data from on my head. And then we have index, which is not important, times the time the data was received, not important. And samples is actually the interesting part, where I have an array of 12 readings that I got from the EEG chip on this device. So to make our life simpler, I just created a copy of this so we can check it out while we code. And what we are going to do now, we are actually going to take these samples that we get all the time from the device and try to get something meaningful out of them. And we'll do it with RxJS operators. So the first thing we are going to do, we are going to call pipe, and then we'll pass it a few operators that will process our data. And for that, I'm going to magically import a lot of operators. Don't worry about it. It's all open source, so you can check it out later. And the first thing I'm going to do, I actually want to look at data just coming from my left ear, from the electrode that is next to my left ear. So I have a small helper for that called channel names, which maps from channel name to electrode index. So let's define a const left ear, and we'll just look at channel names, the index of TP9. TP9 was my left ear, the top of the graph, if you remember. And then I'm going to filter my readings and only take those whose electrode is the left ear. So now I'm left with just the left ear. No pun intended. And the next thing I want to do, I get 12 samples every few milliseconds. And I actually don't care about all of the samples. I just want to see if they cross a certain threshold. So for that, I'm going to take all those samples and just take out the maximum, because I don't really care about the lower ones if I want to see if it crossed a certain threshold. So for that, we'll use the map operator. We'll take the reading, return reading.samples. Now I want the max, but as you can see in a moment, TypeScript gives me an error. Anybody knows why? Reading.samples is an array. Math.max doesn't take an array, only a list of arguments. And for that, we are going to use a new operator called the spread operator. It was introduced in ECMAScript 2000 something. And now it basically splits the samples and sends them as different arguments to the max method. And as you can see, some samples are negative. I don't really care about the sign. I just want the absolute value. So I will map it with map.abs. So now everything is positive. We are all positive. And we are taking only the maximum from each of those samples array. So we filtered only the left ear. Now we are getting the maximum. And basically, now we are ready to check if the data crosses the threshold. So we will filter again. And this time, we just get the max sample from each reading. And we want the max sample to cross the threshold of, let's say, 80. I don't know, magic number. Hopefully this will work. And then I will start getting only values that cross the threshold. So occasionally I will get numbers that are above 80 that were read from above my left ear. And what I'm actually interested in is getting Boolean values that tell me whether I blink or not, and not numbers. So we are going to map this observable and return true whenever the threshold crosses. But then after some time, you want to return false whenever the threshold falls. So we are going to use a switch map for that, which I promised you at the beginning. And let me write that, and then I will explain you what we are doing. Basically, we will return an observable of true whenever we get a number that crosses the threshold. And then after 300 milliseconds, which is the time it takes to blink, we will return another observable of false. And let's merge those two together so TypeScript won't complain about the types. And why do I have an error? Because I haven't used pipe. That's true. Okay, so what did we do here? Basically, we're getting a number whenever we cross the threshold, and then a switch map translates it to true, and then 300 milliseconds will emit false. This is where the switch map magics comes in. If we get another value that crossed the threshold, let's say after 100 milliseconds, it will cancel everything that it created before. So this timer from before will be canceled. We'll get a new true and a new timer. So whenever we cross the threshold, we get a true, a timer is created. But if we cross the threshold again, because we are still above 80, I will get a new true. The old timer will be cancelled, and I will create a new one. So basically, whenever I blink, I will get a true or a few trues, and then after 300 milliseconds, after the graph falls below the threshold, I will get a false. Did you have a question? Okay, we'll talk about it later, because the bounds could work in a way, but there is some nuance, but we can take it later. Thank you, by the way. And then if we cross the threshold and we have a few values crossing the threshold because the graph stays high for a few milliseconds, we'll get multiple trues and then 300 milliseconds false. And we don't want to get multiple trues, so we'll use distinct until changed, which will just give us the first true. And then if we get subsequent true, it won't return anything because it hasn't changed. And return false. And why isn't it happy? Did I import it? I did. Okay. No, it's not happy. Missing comma. Yes, who said that? You are my hero. Thank you. That was a good one. So now, basically, we are going to try that again. Let's add the word blink here. And hopefully, whenever I blink, I will see a blink on the console. Let's try to pair with, let me put it on, and try to pair with it. Let's just adjust it so it will actually pick up my blinks without too much noise. Okay. We are going to try to pair with it. Will it pair? It's connected. I'm going to blink. And it's not doing its thing. Let's try the thing that worked before for us, which is reloading the page and connecting again. Please work, live demo. Muse pair. Are we ready? I clicked connect. Oh, maybe I set the threshold to low, but let me try stand really still. And then I blink, I blink, I blink, I blink. So it's sort of working. There is still some noise. We'll fix that by trying to set a threshold to 100. I hope it will filter some of the noise. But it's not really user-friendly because it's printing stuff to console, right? And as developers, we can open the console, but users can't. So let's enjoy the fact that this is done with Angular to create a UI for that real quick. I'm going to save this observable into a blinks observable of type, it will be a observable of booleans. And then I'm going to say this.blinks equals to all this happiness. So basically, instead of printing to console, I just save it. And it's not happy because, oh yeah, it's observable of booleans, not of just true. Thank you, JavaScript. So now I got the observable of the blinks, which will be true when I blink and false when I stop blinking. And now I can visualize it. So let's create a new div with the class of an eye and put there an eye emoji. Not two eyes, just one eye, because emoji, eye emoji. And what I'm going to do, I'm going to use this nice async pipe. So whenever I blink, I will take the observable, pass it through the async pipe, and whenever it gets through, there is a clap. Whenever it gets through, the blink class will be applied. So this element will get the blink class. Let's do some styling because we love styling. So let's give me a color for the eye. Actually, give me a size for the eye. Numbers? 22 what? Okay. You like to go large. Fair enough, fair enough. I asked for it, right? And then let's set the class for the blink. This time I won't be adventurous and I won't let you pick the color. I will go for salmon because we are in Scandinavia. So basically now, this is all the code that I needed to subscribe to the observable and visualize the blinks. Let's see if that works. Viking brain, please connect. Let's see. Let me put it on again. Oh, you don't need to see it. Is it working, HDMI? Let's restart the HDMI. Let's restart the computer. It's there? Perfect. So now you can see me, and you can see my very big eye. Thank you, Tara. I'm going to try to connect. I need to click pair. By the way, this is dialog from Web Bluetooth. It shows this dialog. And hopefully, if blink, 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 blink. Now I didn't, I lied. Blink. So basically this is working. And only somebody is happy about it. And what do you say? Do you want a cool demo to wrap up or not? Yes, okay. Because I see you weren't so excited about it. So luckily, I got here another project from another talk of mine, and this is this smart bulb. And I don't know, I'm going to try something really crazy. I hope it works. I'm going to try to connect this smart bulb with the project that we just built. And I'm going to show you one of my favorite development methodologies. It's called SOD, which stands for Stack Overflow Oriented Development. Basically, I'm going to copy-paste the code from one of my blog posts about Web Bluetooth. So you can read the post later, but this time we're going to use the Web Bluetooth, the raw Web Bluetooth API. And I'm sorry, I wrote this a few years ago, so it doesn't use async await or anything like that. It just uses then. So before we go copy the code, let me just add a new button, connect bulb, and this button will have a bulb emoji, of course. Let's paste the code that we just copied into connect bulb. Again, this is like a raw raw Web Bluetooth API that I copied from my blog. And if you are sharp, you will be able to spot the next error. So I do a bunch of things. They are explained in my Web Bluetooth tutorial. And basically, I get something called characteristic, which I can then use to send data to the bulb. And I'm going to save it to my class. And whoever spots the error first gets a sticker. Anybody? Okay, I will declare. That's not an error, but yes, that's fair enough. I will declare it. What's the type for that? Finally, I found it. Anyway, you didn't not spot it, so you don't get a sticker. But the problem is I'm not using an arrow function, so this is not defined. Unlucky me. I'm going to switch to an arrow function, so now this will be bound. And basically, this is all the Web Bluetooth code to connect to the bulb. Now, another thing I'm going to copy from the blog post is the setColor function. It's very nice that I can just copy-paste. And then we are going to call this.bulb characteristic.writeValue. It doesn't like var. Let's fix that. I need to save. Now it's changed to let, const, everything is fine. I like when TS-Link fixes my code. And then we have this setColor method that basically writes the RGB value to the bulb using some protocol. This is a Chinese bulb, $10, so with some strange protocol. And what I'm going to do, I'm going to connect my observable with a bulb. So I subscribe to it. Remember, it returns, let's call it is blinking. It returns true whenever I blink, false whenever I stop. And then I can say if is blinking, this.setColor, give me some RGB real quick. Red, green, blue, please, real quick. Color, anybody? What color would that be? Pink! Okay, let's see. Let's try that. Missing semicolon. Okay, so basically, I just copied the code to connect to the bulb, and I connected it to my observable. And now, if everything works, I can refresh the page because we learned that we need to do that for some obscure reason. I'm going to try to, actually, let's start with connecting with the bulb. I'm going to try to connect with the bulb through Web Bluetooth, so device number 1. Now, I didn't read connected, my bad, I hope it connected. I'm going to try to pair with the Muse. Let me put it on and hit the pair button. And if everything works, it will say connected. Yeah, I think we have a bug here. Do we? This.setColor. Anyway, it's pink. Did anybody spot a bug? We call set color. Maybe I'm constantly blinking. Let me try to adjust it so it sits on my brain correctly, because there is a good chance I'm just picking up noise. Let's refresh the page. Go, turn off, behave. Okay, let's try to pair with the bulb again. That's one annoying thing about Web Bluetooth. You have to reconnect to the device whenever you refresh the page. Hopefully they will solve it in the future, and I'm connected. I think it sort of worked. Let's try. Interesting. Okay, sometimes the computer introduces noise. So I'm not really sure why the... Oh, wait. Does it have to do something to do with the HDMI? I don't know. Maybe it's the mic or something that is disrupting the signal, because it worked before. But anyway, imagine that now this is what it should have been like. And what I want you to take away from here, I think it's amazing that we have this opportunity with so little code to take what we already know about RxJS and about Angular, it worked, about RxJS and about Angular, and start, don't behave, it's playing game with me, and start building things that interact not just with the web page or with a smartphone, but with devices around us, like the smart bulb or with this EEG headset. So this is how I switch it off. And I really want you to go home and think where we could apply this. I mean, this thing can be used for people with certain disabilities. Oh, it worked. They blink. I don't know why, but it started working. I'm trying not to move, so it won't stop working. Miracle. Ready, set, blink, 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 blink. If they are recording the screen, let's get one for the screen. Now the audience at home is not knowing it doesn't know it didn't work. They think it worked all the time. Anyway, blinking, it goes on. So, again, I want you to remember, we live in a... Thank you. Now go home and build something cool. All the slides are Twitter, and feel free to ping me on Twitter if you want to talk about this. Thank you.
Wow.
Thank you, Martin.